Welcome back. Continuing with our previous work about quartiles and Mitty's Trivia Murder Party scores in thousands of dollars, where we had come in and found the quartiles, defined and found the quartiles based on the textbook. If we have an odd number of data values, we're going to throw out that median when we're calculating the middle of the two halves of the data. And what we have now is a new measure of variation. We've already had the range, the standard deviation, and the coefficient of variation. But now we can define a fourth measure of variation called the inner quartile range. And that is defined simply as the third quartile minus the first quartile. So, and by that what we mean is those actual breakpoints. If we come back and look here, our third quartile was 31 and our first quartile was 7. So 31 minus 7 is equal to 24. And all that's basically saying is it's just kind of telling us how far is it from this number to this number. Just what's the distance between these two numbers. It's very much like the range in that the range is telling you the distance between the highest point and the lowest point. That's the range, is that distance there. It's very similar, except it's just telling you the range from the third to the first quartile. What it's telling you is how spread out is the middle chunk of the data. Because from the third to the first quartile, you're talking about roughly 50% of the data, but it's kind of the middle 50% here, right? It's sort of the middle 50%, and it's saying how spread out is that? And what it's going to allow us to do is to kind of see, all right, well, that is the data sort of clumped in there, or how much is going on the outside. We're actually going to have a visualization of that in a little while. I will remind you that the range, which is one of our measures of variation, is always the maximum data value. So in this case, capital M sub max minus the minimum data value. So capital sub M min. And again, reminding ourselves that was 53 and 2. So 53 minus 2 is 51. And that's just saying, here's the total spread of the data. It's 51 units apart. And this is saying, what is the spread of the middle half of the data? It's about 24 units apart. Those numbers are not necessarily supposed to be half of each other. That's just a coincidence of the numbers that I chose here. So that's a new measure of variation, and that's going to really show well when we look at something called the Box-and-Whisker plot. Before I do that, I just want to point out how we don't have this issue about whether or not to include the median if our data values, if we have an even number of data values. Here I threw out a couple of numbers, so I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 data values. So the median is between the 7th and the 8th one, 1, 2, 3, 4, 5, 6, 7, and the 8th one. So the median is actually right here, halfway between those. Halfway between 19 and 23 is 21. So now if I want to go and calculate the median of the first half, what's called the first quartile, it breaks very nicely, and I don't have to worry about including the median in either of those halves because the median was in between two data values. So it wasn't even really technically in the set. So 1, 2, 3, 4, 5, 6, 7. Now I have an odd number. So the median is the fourth one. So my first quartile is 11, 1, 2, 3, 4, and my third quartile is 31. And my IQR in this case would be 31 minus 11, or 20. All right. Let's go see how that interquartile range actually looks, though. See what it really looks like. We're going to create something called a box and whisker plot. Before we can create a box and whisker plot, we do need to have the mean, not the mean, sorry, we don't need the mean. We need the median, we need the minimum, so we'll use a capital M. The minimum we said was 2. We need the first quartile. This might be a reason to actually go and use the full 1, is so I can put a subscript of M. So the first quartile, I'm going to go back to the original set of data. The original set of data, we had a 7 as our first quartile. We had the median of the data. So there, the median of the data was, for us, it was 19, and then don't forget that number 31. So the median was 19. The third quartile, wow, that looks bad. Oop. The third quartile for that was 31, and the maximum of M, so I'm kind of switching where I put the subscript on things. Just kind of a weird thing there. Maybe I'll need to make some decisions about that, and I believe that was 53. So we need all of those numbers and have to calculate them first or find them before we can go and do our box and whisker plot. But here we are now. We begin with a number line. We have what's called one variable data. We're only measuring things, for one category, for one kind of measurement. So it's one variable data. So we only need one line. We're not doing two variable. We do not need a coordinate grid. And on there, I really like to always show 0 and start out with 0. And then I need to come in and put some markings. Need to put some scale on here. If I got to go up to 53, I need to probably get to 60. So let's try this. Maybe 10, 20, 30, 40, 50, 60. Of course, that really should have been measured out a lot more perfectly. Don't really have a good way of doing that on here for now. So I just tried to make sure it looked really pretty good. So here's how you make your box and whisker plot. You come in here and you start by placing a point. Let's go with a cool color like that. I'm going to place a point at the minimum. Our minimum data value, as we saw over here, hopefully you can still kind of see it, I can, is a 2. So if this is 10, 2 is 1/5 of the way. So we come up here a good ways off of the number line, and we put a dot, a big full dot for the minimum. Actually, it's a little too big. Then we come over and we find the first quartile. Our first quartile was 7. So 7. And what we do is we put a bar, and that bar needs to have its height be in such a way that the dot lines up with the middle of the bar vertically. Lines up with the middle of the bar vertically. And in fact, what we're going to do then is we're going to connect between that bar and the dot with a line. So there's our first quartile. We mark it with a bar. We come in and we mark our median. Our median was 19. Be about right here. That you mark with a similar bar. It's getting a little messy there. So you mark that with a similar bar that has its top and bottom in the same place as the first bar. Our third quartile was 31, so we're going to come in here, mark one more bar at 31, and then we connect across, and those should have lined up. We connect across, and there is our box, and you can see our first whisker over here as well. And then finally we place a dot at our maximum, which was 53. Again, it should be in the middle of the box, line-wise. That's not going so well for me, since I'm having to do this on this new pad instead of like I do at the board. Anyway, so there is my box and whisker plot. But I actually want you, when you make these, to go in and label everything. I'm not going to worry about the subscripting. So our minimum is 2. Our first quartile is 7. Our median, and I believe this is what the book calls the 5-number summary. So we're going to come in and put our 5-number summary. Our third quartile was 31, and then our maximum was 53. So why a box and whisker plot? What is this all about? Well, it's basically kind of trying to show us how the data is grouped and clumped. What you can see is that a large chunk of the data was over here below 31, and then the maximum was almost twice as much as where the cutoff was for about 3/4 of the data. About 3/4 of the data lie below 31, at or below 31, and then 53 is not quite twice that, but not quite twice that is where your maximum was. So this last quarter, this fourth quarter, was pretty spread out. And over here you got a lot more clumping. Your first quarter was really clumped together. So it's a nice way of, a quick, easy way actually, of kind of seeing how the data is spread out. It's not as good as a histogram. We've already looked at histograms. They show us a lot better how the data is spread out because you get to put it in those different buckets, and you can put a lot of different buckets. We kind of are just grouping things in just 4 sort of clumps here. The first 25% of the data, the second 25% of the data, the third 25%, and the fourth 25% of the data. Give or take, it's not exactly 25%. But it's a super easy, quick way for us to get a look at that data, sort of see where it's clumped, see what's happening with it. And the one other piece that you can see on here that we had calculated is that this distance right here is what we had called the interquartile range. That right there is the interquartile range, whereas this distance overall was the range. So it's giving you a really good visual. Rather than just saying the range was 51, which doesn't really say a whole lot without comparing to the other numbers. This box and whisker plot gives us a really nice way of visualizing what that range means, what that IQR, that interquartile range means, shows us how the data is clumping, at least as far as the different quarters of the data. So it's a really great visual. There are ways to create this on the graphing calculator, which I don't have time to show you. And you can also do this, I'm assuming, on RStudio, which will be something you are going to be looking for as your investigation.